Hello everyone, this is a paper 1 2019 A-level mathematics, and this is exercise 5 continued from the last lesson. We continue the paper from the last lesson. In the first part we need to write the quadratic in completing the square format, a bracket x plus b squared plus c. So first thing to do is to factorize the quadratic, taking the 2 out of the bracket, and then we apply the method using the x squared plus 2x plus 9 over 2. So it have to be x plus 1 bracket square. We subtract 1 and then we add the 9 over 2. Because I don't want the 1 square, I have to subtract this and then I add the 9 over 2. I close the bracket. I add the 2 fractions at the end and I have minus 1 plus 9 over 2 give you 7 over 2. And after I times by 2, I have the completed format plus 7. And this gives me the minimum point of the parabola. So the minimum point of the parabola is negative 1, 7. So this will help me for this part B, because in the part B I ask you to sketch the curve with equation y equals f. So to sketch this, you may also need the y-intercept, but it's very easy to find the y-intercept. You make the x equals 0. And since I have the y-intercept is 9, the f0 is 9, and I already have the minimum point as minus 1. The minimum point is negative 1,7. And you already notice that it's above the horizontal axis, which means it has no x-intercepts. And there is no need to find any x-intercepts here. And now you can sketch the parabola in this way. Okay, so you make it a parabola, minimum point minus 1,7, crossing the y-axis at 9, and this is the sketch. Sketch doesn't mean it's not an accurate graph, so it's a sketch of the parabola. So you don't need to be an accurate graph. Now let's go to number C. Let's go to number C. Describe fully the transformation that maps the curve with equation y equals f. This is the original function of the parabola onto the curve with equation gx. The gx is 2 bracket x minus 2 bracket square plus 4x minus 3. Now by comparing the f and the g, you already notice something, that the 2 is the same. The value of the x here has been replaced by x minus 2. And if they ask you for transformations, then you get an idea what type of transformation it may have been. For example, it may have done, you replace the x with the x minus 2. So this is a transformation. This is a transformation that is a horizontal translation, because from transformations I may have the function f, and to draw the function fx plus a, this is a horizontal translation by a units, right or left, depending on the value of the a. So the first thing to notice here is the value of the x has been replaced by x minus 2. And you need to check whether it's a horizontal translation. So if we have the function f is 2x squared plus 4x. The function f is 2x squared plus 4x plus 9. You need to check whether we have the function g is the fx minus 2. And we need to see whether we found the function that the g. So I try to find the x minus 2. The function f(x minus 2), I replace the x with the x minus 2. And I need to check now whether I have the g function. Now, doing the calculations here, you simplify the brackets, okay, you expand the brackets. Now the function g here is the 4x minus 3. So it's a good idea here to expand the second bracket and keep it the first bracket like this, square, but you expand minus 4x minus 8 plus 9, and this give you the final format. 4x, this is plus 4x plus 1, and let's see the function g. The function g is a minus 3, so it means that except the horizontal translation, you may have another transformation here. It can be also a vertical translation as well, because I need to go to negative 3. The other transformation that we are considering here is a vertical translation, because I need to have exactly the same value of the g. The vertical translation, I have the function f(x), the original function, and I add a number at the end. This type of transformation is a vertical translation. So I need to go from the plus 1 into the negative 3. So this is a vertical translation by a units. By a units. So in this case, because I want to have the function g, and the function g is negative 3 at the end, I need to make another vertical translation, minus 4, from plus 1 to go to minus 3. So I did one horizontal translation of the function f by 2 units to the right. This is a horizontal translation. Two units right. And I'm going also to do another vertical translation. Four units down, because if I subtract a negative 4 at the end, I have exactly the function g, and this helped me answer the question now. So 4, 1 plus 1 minus 4 give you the function g. And it says describe fully transformation that maps the curve f into the g. So the transformation are one horizontal translation 2 units right, and one vertical translation 4 units down. Okay, and now this is the answer of the part C. And now we go into the final part of the question, which says find the range. Find the range of the function 21 over 2x squared plus 4x plus 9. Now we have the range of values of the quadratic. Okay, so let's see how to answer this one. We have the range, we can find from the graph, from the sketch, we can find the range of the parabola. Okay, the range of the parabola, this is the parabola here. Let me copy this, and it's because we already have the diagram here. Yes, I have the parabola 2x squared plus 4x plus 3. From the sketch I made here, I can find the range that is greater or equal to 7. Greater. Function f is greater or equal to 7, because the minimum point is -1 comma 7. And the function that we are considering here is h is equal to 21 over the parabola that we already sketched on this part. And the function f doesn't go lower than 7, so this is the minimum value for the function, and this creates, if this is the lowest value, creates the highest value of the h, and the opposite, if I increase the values of the denominator, I reduce the values of the h. And this helped me find the range of, because I already have a maximum, this function, the h, has a maximum at 21 over 7, because this is a lowest value and denominator, and this shows the range. It doesn't go higher than 21 over 7. And you can write here the h is less than or equal to 21 over 7, and this shows and this shows the range of the h. 21 over 7 is 3, so this is equal to 3, so it doesn't go higher than 3. It's an upper limit, and this answers all of the parts of this question. Let's continue the paper. This is number 6, trigonometry, finding solutions of trigonometric equations. The values of theta must be minus 180 up to 180. And here the equation is 5 sine 2 theta is equal to 5 sine 2 theta is equal to 9 tan theta. You notice something here, that the sine is a double angle formula of the sine theta, is sine 2 theta, that we have identities. So the sine 2 theta, I can replace the sine 2 theta with 2 sine theta cos theta, and this is equal to 9. The tan theta has an identity, is an identity, sine theta over cosine theta, so you write sine theta over cosine theta. And now you simplify the equation, rearranging, you times both sides by cos theta, so you have 5 times 2 is 10 sine theta cos square theta is equal to 9 sine theta. We bring the right hand side, the 9 sine theta, to the left, so we subtract 9 sine theta on both sides, and we have an equation equal to 0. To solve this equation, because I have two functions, cosine and sine theta, I need to factorize. You can factorize this by taking the sine theta out of the bracket, and then I have 10 cos square theta minus 9. This is equal to 0. Solving this equation is simple now, because the two solutions that make the equation 0 is the sine theta is equal to 0, and the other solution is the 10 cos square theta, 10 cos square theta minus 9 equals 0. So the cos square theta is equal to 9 over 10. So we have two solutions here. The one is cos theta is plus minus 3 over square root of 10. So I need to solve these three trigonometric equations. I have one equation here, and I have two equations with the cos theta. So I need to solve all of these equations using the interval minus 180 and 180. We start with the sine theta. Let's solve the equation sine theta is equal to 0. By using the unit circle, we can find the solutions of the theta. So for the sine theta, I use the vertical axis, and the vertical axis represents the sine theta on the unit circle, because I have a unit circle here. A unit circle is a circle with center the origin, radius is 1, so I have 1 here, plus 1 here, negative 1 here, negative 1 here, and divides into 4 quadrants, the plane into 4 quadrants. This is the first quadrant, this is the second quadrant, this is the third quadrant, and this is the fourth quadrant. And I want to find all the angles that have 0. The theta, the value on the vertical axis is 0, so it has to be the origin. So one angle is 0, okay, because we start from the horizontal axis and we go anti-clockwise. For positive angles, we go anti-clockwise, and for negative angles, I go clockwise with the unit circle. So one angle is 0 and is inside the range, because the range is minus 180 up to 180. Okay, so I check, and you see the range is including the minus 180 and less than. Another angle that give you on the vertical axis 0 is have to be 118 degrees, because this is included. So one angle is the 0, another angle is the 180. Because if you go a straight line, you have exactly 0 on the vertical axis. Okay, you go another one, 0. And we need to go and check now for angles for the other equation. The other equation, actually we have a negative 180 as well here, because I can also go clockwise and on the horizontal axis into minus here, and then I can go clockwise, and this is minus 180. So the other solution here is negative 180. And now I'm going to solve the equation cos theta is 3 over root 10. So I can make a unit circle again and use the horizontal axis to find solutions. So I draw the vertical axis, the horizontal axis. This is a unit circle, and I want to solve the equation cos theta is equal to 3 over square root of 10. For the cosine theta, I check on the unit circle of the horizontal axis, and I want the decimal 3 over root 10. 3 over root 10 is approximately 0.9495. So I want the angle to be on the horizontal axis here. So the first angle I found on the calculator by using the inverse. So by using the inverse, I found the first angle. And this gives you the angle 18 degrees, 18.4, which I need to sketch, I need to draw it on the circle. So this is, yes, it's 18 degrees. You see, I check on the horizontal axis, and I need to have this value here, which is 3 over root 10. So this angle here is 18.4. And let's see the range. The range is between minus 180 and less than 180 plus. Another angle that gives you the same value, 3 over root 10 on the horizontal axis. This is the first quadrant. So I have one solution on the first quadrant. The second quadrant, there is no solution because the horizontal axis is negative. The third quadrant, there is no solution because the horizontal axis here is negative. So the fourth quadrant is a solution here because I can find another angle below. And if you see on the horizontal here, I go to the same point, 3 over root 10. But what is this angle? Is minus 18.4. So this angle here is minus 18.4, which is inside the range. So the two solutions for this equation is theta 1 is 18.4 and the second value is minus 18.4. And let's go to the other equation. The cos theta is negative 3 over root 10. And here I go in the second quadrant because I check on the horizontal axis. This value is minus 0.9. So it's about here. This point here is minus 3 over root 10. So the angle here must be on the second quadrant. The solutions have to be on the second quadrant or the third quadrant. See, these two angles have on the horizontal axis. You go and find so the first angle here, you check on the calculator, you find the angle theta with the inverse. So which angle give you minus 3 over root 10 cosine? This angle on the calculator, you find this angle on the calculator. Is 161. So it is plus 161.5, or you round up to 166, 0.6. And I need to see the range. The range is minus 180 and 180. I go for the anti-clockwise, I go plus, is the positive angles. Is 161 is one solution, is another solution. And I have to go clockwise for negative values because it's inside the range as well, the minus 180. So the other angle is minus 161.6, and I found all the solutions of these equations. Let's summarize the solutions. The solutions, I check the sine theta is equal to 0. This gives me 2 solutions. Give me 3 solutions. Let's write the total. So the solutions here are 0, 180, minus 180 for the sine theta. And for the cosine theta, I have 18.4 and minus 18.4. 18.4 and minus 18.4. And for the other cosine equation, I have 161.6, 161.6 and negative 161.6. So for solutions, I check the unit circle, and for if I have the cosine equation, I check on the horizontal axis, all angles on the horizontal axis, and for the sine equation, for the sine theta, I check the vertical axis. And then I found all these solutions that are the answers to this exercise, okay, for the first part. And this exercise has also a part B. Deduce the smallest positive solution to the equation. 5 sine bracket 2x minus 50 is equal to 9 tan x minus 25. So we go and see the solutions. The smallest angles are basically I make the theta to be the x minus 25, the angle, and I make an adjustment actually. Okay, so if it's, we found already the solutions are minus 18.4, and then I add 25 and I found the lowest value for the x. So in this case I need to make the angle theta to be the x minus 25, and the x must be theta plus 25, and the lower value for the theta is minus 18.4, so the x becomes minus 18.4 plus 25, and this gives you a value of 6.6 degrees, and this answers the second part, because the minus 18.4 give you the lowest possible value of the theta we found in the previous part, and after the adjustment of the 25 give you the 6.6. And this brings us at the end of this lesson, and if you like the lesson, please subscribe, and we can see you next time. Thank you.